This is our introduction to exercise 6B, right? 6B will just talk about the index laws 1 and 2. As I mentioned last week, it does not matter which law is which. I will never ask you, use index law 2, and you can only use index law 2. I don't care. I just want you to solve or factorize, simplify, whatever it is. I don't care which law is which. They just make nice numbers to make it easier to learn. We'll start with our do now question. Our do now question is to find the prime factorization of the number 120. I'm hoping you gave that one a go. A prime factorization of 120, which means to break it down into its prime factors. I like to use that tree method. So I think, what number goes at 120? Hopefully this sounds familiar. I know that when in doubt, just use 2. Just to be different, I'm not going to use 2. I'm going to use 4. 4 and 30. Your answer should be the same regardless. I'm going to use 4 and 30. I know that 4 splits on 2 and 2. As in 2 times 2 is 4, easy. I know that 30 splits off into, for example, 2 and 15. I can't split 2 up anymore, so I'm going to do 15. I know that splits up into a 3 and a 5. And you'll notice that all the ends of my tree are all prime numbers. They're numbers that don't have any other factors besides 1 and themselves. So 120 equals, I have 1, 2, 3, so 2 to the power of 3 times, I have 1, 3, so times 3, and then times by 5 in the end. Okay, so that's 2 to the power of 3 times 3 times 5. That will be an answer of the prime factorization of 120. It's the prime factors of 120. Good, okay, so now that we've learned about index laws in terms of, indices, just what are they, we're going to learn about the law 1 and law 2, which is the easiest law imaginable. Okay, it's very easy, but it's also room for error, because you do not do index laws in year 8 or year 7, so this is entirely new. You need to make sure you know those laws, but they are very easy, I promise. The first law, I'll get you to copy down if you haven't done so already, is a to the power of m times a to the power of n. Do not ask me why they use m and n. They are very similar, unfortunately. But that's just going to be a to the power of m plus n now. M plus n. That's just the law. Note 2 things. Number 1 is that the base, or the number that is on the bottom, is the same. This law only works if the base is the same. The second thing you'll note is that when there's a times in between, you add the powers. That is it. That is the entirety of the law. Let's do an example. If I, for example, have, and I'll get you to copy this example next to your law 1. Damien, are you doing a pat test? Are you doing a pat test? Give me a letter and a number. A. 12, and then give me another number.
L.
Sorry?
L. Oh, no.
Number, yeah. Can be positive or negative. Five, easy, okay. 12 times a to the power of negative 5. The formula is, we're assuming again that the base is the same. It doesn't have to be A, he's just chosen A. It could be any letter or number. As long as they're the same, all I'm going to do is add the power. So it's a to the power 12 times a to the power negative 5, which means using my law, I keep the same base and then add the powers together. So 12 plus negative 5. Yeah? 12 plus negative 5, well, that's just going to be 12 minus 5. So a to the power 7. Done. A to the power 7, that's it. Pretty straightforward. Christos. Keep looking back at your laptop, I'm a bit worried. That's the entirety of the law. Anytime you're multiplying, you add the powers. Okay? A mistake that's very common. Remy, please stop doing that. Another thing that's very common is that students will misread that as a plus and then times the powers. You can't do that. It has to be timesing to add the powers. So if that's our law number 1, what do you think happens if we go a to the power of m divided by a to the power of n? What happens then? Instead of adding the powers, we minus. I'm noticing a lot of people not. We just minus. So in this case, it's a to the power of m minus n. That's it. That formula is just the direct opposite. That's it. You might see it like this. I'm going to rewrite it. Or a to the power of m me just cross that off. A to the power of m over a to the power of n. That is still the same thing. A to the power of m minus, a to the power of m minus n. That's it, it's the exact same thing. I'm going to jump straight into a relatively tricky problem, and I just want you to work through with me, okay? I'm going to get rid of our do not question. And I'm going to say, okay, give me a letter. Again, give me a different one. D. Okay, so d to the power of 42 divided by d to the power of 10 over d to the power of 8. Looks like a very complicated question, doesn't it, guys? We're doing the exact same thing. Yeah? So I'm going to look at the top. Let's ignore the bottom for now. D to the power of 42 divided by d to the power of 10. I've just got to minus powers. So it's going to be d to the power of 42 minus 10. And I'm going to leave the bottom as the same for now. I'm going to get everyone to copy down that example that I've written down. Well, I know that d to the power of 42 minus 10 is d to the power of 32. And I'm going to keep the bottom. I'm going to show you what a lot of students do wrong. Please do not copy this next part. They go, okay, well, d to the power of 32, d to the power of 8, I'm dividing, so that means why not 8 goes to 32 4 times, d to the power of 4. Why is that wrong? Yes? Thank you very much. According to the formula, it's d to the power of 32 minus 8, not divided by 8. So I would write here, please copy this part down, which equals to d to the power of 32 minus 8, which is d to the power of 32 minus 8, which is 26. Relatively large number, but that's it. You don't need to solve it, you just simplify it. You just simplify it. Thank you. It is indeed 24, not 26. Thanks, Far. Did I make you feel like you were stupid for a second? Alright, one more example, then I'll get you guys to get started. Last example, I'm going to throw a little bit of a curveball at you. I'm going to say x to the power of 7 times 2x to the power of negative 3 divided by x, or so we'll say y, to the power of 2. That's a bit of a curveball for you. Again, it is very easy, you just need to know our laws. Okay? So, here, x to the power of 7 times 2x to the power of negative 3. Let's just treat the numbers as they normally are. Cancel, what number's here that actually isn't there? What number is actually in front of the x that I have not written there? It's a 1. So I just do 2 times 1. Well, I know that's 2. I'm going to leave the numbers as they are. Now let's do the powers. X to the power of 7 times x to the power of negative 3. Well, I know that's x to the power of 7 minus, plus, my apologies, negative 3. I'm adding the powers. X, so 7 plus the negative 3. That's just the formula. The bottom I'm going to leave the same for now. Y to the power of 2. I'm going to simplify that. 2x to the power of 7 minus 3 is 4, all over y squared. This next bit I'm going to write in blue is going to be incorrect. Please do not write this down. Bless you. A lot of students do this. 2x to the power of 4 minus 2. So 2. Done. Damien, why is that wrong? Thank you very much. They are different bases. Yeah, x and y, they are different. We cannot do that. So our final answer would just be that 2x to the power of 4 over y squared. That's it. That's all you can do. Any questions? From this point onwards, it might be a little bit tricky. But index law 1 and 2, which I don't care whether you know which one is 1 and 2, doesn't matter, right? From that point, it's just an application of those formulas. I'll get you guys started on exercise 6B. I'll put the questions up on Compass as well if they're not already up. Thank you.